Wi-Fi podcast. How's it going?
It's going good. So everybody knows it's 6:30 on the West Coast.
No,
so
really?
I just want to remind everybody I'm up at 6:30.
Bryan, come on. You gotta get up early.
It's only 9:30 your time. So.
I know. So, alright, so I got the new iPhone 13 Pro, and I tested the Wi-Fi on it, and guess what? It's slow. So I haven't seen this before. Like, whenever the new phones are released, usually the code on it's pretty good where I'm getting, impressive numbers. But I tested the Wi-Fi on the iPhone 13 Pro, and I'm only getting about 600 meg throughput on this. I've tried with iPerf. I've got it connected directly to the switch, APs to the switch, desktops to the switch, running iPerf, getting about 600 meg, and also on speed test, which people say don't use speed test, but I always see the same numbers because I'm gigabit connected, gigabit Ethernet. I mean, yeah, there's other factors there, but they're both pretty close to 600 now. With the iPhone 12 Pro, I saw closer to 800.
You're doing tests on both?
Yeah.
Very similar?
Yeah, I mean, they're similar. Unfortunately, I sold the 12 Pro immediately, so I wasn't able to test them both on iOS 15. But, I'm running the release version of iOS 15. Once I got the 13 Pro, I reflashed it with the release version, and then I did the testing, and I'm seeing like 600 meg maximum on a 2x2 2x2 radio built in here at 80 megahertz. I'm seeing around 600, and I'm testing it with the Ruckus R750, and I'm also testing my laptop at the same time, and I'm getting like over 800 meg with my laptop. So it's not the access point of the network, it's the phone. So I'm thinking they probably have some like beta code on the 13 when they sent it out, because it also gets really hot when I run these tests. Yeah, so I'll run the test a couple times, the phone starts getting hot, and yeah, I mean, it would happen before, but I think there's something with the drivers, they have the debug drivers on this iOS 15 still.
It's the same size, right? It's the same size.
It's the same size, but it's a little heavier. So they put a bigger battery in that camera island's a lot bigger. It sticks out. so it's like you can't use the same case. It looks the same, but you have to get a new case, of course.
Oh. You got a case for it and everything.
Yeah, you gotta get a case, everything for it. So I go for the Apple one because I've never broke one yet. So I give them the $50. So anyway, yeah. So if anybody has done similar testing with the iPhone 13 Pro with Wi-Fi 6, let us know in the comments. I want to see what other people are getting. I tried reaching out to Reddit and a couple other forums to see if anybody else was seeing this also. It'd just be interesting to know. I'm sure they're going to upgrade to iOS 15.1 soon, because there's a couple other bugs that people already reported with the 13. Like, you can't unlock with the Apple Watch. A couple things like that drive me crazy. So, all right, so that's...
I'm gonna sell my 12.
You're going to sell it? You're selling it, huh? You're keeping it. Okay.
Yeah, I'm going to keep it.
All right, so then we wanted to talk about Wi-Fi data rates. So you mostly will see this on your computer if you look in the network manager, like when you're on Windows 10 and you're connected to Wi-Fi. If you look at the network adapter, you can see what rate that you're connected at, right, Bryan?
Yeah. Yeah, you can look at like your Ethernet adapter, and it will tell you the data rate, or they might call it the link rate.
Yeah, we were talking about this earlier. Like, there's different wording for it, but it's all relative to how far you are away from the access point, what type of Wi-Fi adapter you have, as to what these data rates you're going to see. Now, this can help you kind of troubleshoot performance numbers that a customer's seeing, right? Like if they're like, oh, I'm only seeing 150 meg, if you look at their computer, yeah, maybe they have a 11N chipset in there, and they're connected at 300 meg, and maybe they're seeing like 150 or less, right?
Yeah, I mean, the data rate gives you a lot of good information because you know, I always reference the cloud because I'm constantly working in the cloud. So if you look at, like, we have a thing called client list that shows all the clients that are wirelessly connected. And one of the things that shows you is RSSI and data rate.
Yeah.
And so data rate, yeah, it gives you a good indicator of like, okay. Well, it also tells you if you're connected to 2.4 or 5, right? So that's another indicator too.
Mm-hmm.
But yeah, you can see what it linked up at or connected at a particular time, and so that can give you a lot of information about like you're saying, like the client device itself, where they were within, not exactly where they were, but how close they were to like an access point, for example. Because if you have a slow data rate versus a high data rate, you might be further away from the access point, for example. So it gives you a lot of good info in regards to what's happening. If you have like a problem with a particular client, or a particular network, that's a good indicator. It tells you like, okay, you have too many APs or not enough APs, or the AP placement is just wrong. You start to think about like the whole network and how it's working. But yeah, the data rate, like we talked, whatever that data rate is, pretty much you should cut it in half, right?
Yeah. So whatever you see. So if you let's talk about Wi-Fi 6 because I'm looking at the Wikipedia page right now. So if you're, all these business class access points are maximum 80 megahertz mode, and that's probably what you'll run it in unless you have like a real high density situation. So 80 megahertz mode, each Wi-Fi 6 stream has a maximum of 600.5 megabits per second. Due to this chart here. Now you have a 2x2 adapter in your computer, so you see the link speed's 1200 meg, 1.2 gig, right? Now, if you get that link speed and you run some tests, you'll see with Wi-Fi 6, you'll see slightly better than half, because they keep improving efficiency. As the newer standards come out, with like 11N or 11AC, you'll probably see less than half. Actual throughput, and you were talking about bandwidth versus throughput. Like, explain that to me again.
Explain that.
Yeah, because I know you're doing some documentation.
Yeah, no worries. So bandwidth is like the theoretical speed.
Right.
So you might have let's think of like just a switch. So the switch port might be 1 gigabit. That's the theoretical speed. But connected to it, you might not get exactly a gigabit. You might get slightly less, or we use theoretical speeds on Wi-Fi all the time.
Yeah.
You know what I mean? Like you're gonna get 866 megabits per second, and that's theoretical speed. So that's the capacity, the potential capacity. But throughput is the actual, like what you actually get. And that's what we're kind of talking about. We're talking about the actual versus the theoretical. So like the data rate is the theoretical speed, or the connection rate is the theoretical, basically, and then the actual is what you're actually getting. Like if you're running like a speed test, or
iPerf testing. Yeah. So the other thing is so that you're never going to actually see that data rate. That's just like it's just like a modulation scheme that the two radios are using to talk to each other. So they're connected at this modulation, and they have a theoretical maximum of 1.2 meg. So you have channel width, 80 megahertz channel. You have two streams. You add those together, you get 1.2. Now it's just like in the old days when you had a 56K modem. You're never gonna get 56K. They would just talk at a faster speed, so maybe you get like a little bit better than 2400 baud modem. So that it's the same thing. They're using or like a fax machine. They're negotiating that rate, and that's what they're gonna talk at, but they're not actually sending at that rate.
Right.
Now the other thing you kind of hit on was. By looking at these speeds, you'll see that they're gonna the speed, the further away you get from the access point, the speeds are going to go down, and then at some point you're going to switch bands to 2.4, right?
Yep. Yeah.
So that's kind of how you can kind of tell when you're looking at like the Ingenious Cloud or other clouds. You can tell like how far away those clients are from the AP and if there's enough APs, right?
Yeah, exactly. So that's we'll get calls from either end users or installers, and they'll say, hey, the client is experiencing slow speeds, and obviously they're going to speedtest.com and they're testing speeds.
Yeah.
Right? So the first thing I look at is, okay, you have to identify the client. Like, okay, what client are you talking about, and what are they operating on? And within our interface, you can tell, like, if they're on 2.4, if they're on 5, you can tell which access point they're connected to. The RSSI is another factor. You can look at the RSSI and see what that is. So, you want a really good RSSI reading. But yeah, sure, it eventually leads to, okay, it's not roaming properly, the AP placement is wrong, you don't have enough access points, or maybe you have too many access points. So it kind of leads down that path, and it starts to help you understand kind of the layout and what's actually going on. And, so data rate is one of those components that you should look at.
Yeah, so if you see like let's say you have a Windows laptop, and you look at either the in the cloud interface or the network adapter on the computer, and you're on 2.4 gigahertz and you're at a 1 megabit data rate, then you know that you're really far from that access point, or it's not roaming to the 5.8 interface like it should, right? So
Yep.
So maybe some of the clients are sticky. They'll stick on that 2.4 because they see it first and longest, and they'll never go to the 5.8 unless they're like forced over there. So all right, so that's
Yeah, and we run into that. Sorry to cut you off.
No, it's okay.
Yeah, we run into that, and that's typically like all the things I just said, but also the radio configurations. The output power is too high, the output power is too low, or you have too much 2.4, or there's multiple things there.
Yeah, so if you see something like that, you could turn down the output power on the 2.4 radio, or turn off the 2.4 radio on some access points, right? Maybe every other access point, so that you're going to see more clients, roaming onto the 5.8.
Yep. And just to give you an example, so just looking at my Wi-Fi card, I'm linked at 1.2 receive and 1.1 transmit. On the cloud interface, I was at 1 gig.
Yeah.
My actual speed is 400 by 400 basically.
And is that your internet Your internet connection's 500?
My internet connection's 500 by 500.
Okay. All right. So that's not too shabby. And you're going through mesh.
No,
you're
I'm
not.
direct connect.
You are direct connected. Okay.
Not mesh.
All right. So then.
I'd cut that number in half if I was mesh.
Okay. So next, let's lead into cloud meshing. Now this will be specific to Ingenious because like everyone does meshing a little bit different. So with the Ingenious Cloud, if you want to mesh an access point, you have to have a gateway for it to connect to, and then you have to have a mesh point basically, right?
Yeah. So the gateway is the device that's physically connected to the network.
Right.
And then, so when you look at your APs, you'll have an AP list, and it will tell you, what the mesh mode is. It could be turned off. It could be on. If it's on, it's going to tell you if it's a gateway or if it's an AP. If it's a gateway, it's wired to the network. If it's an AP, it's wirelessly talking to a gateway or another AP that's wired.
Right. So, if you drill down into the Genius Cloud interface, you can enable or disable meshing for the whole network, and then you can disable it for individual access points. Now, let's say that you have one AP that you want to mesh, and it only has one other AP that's close enough that you want it to connect to, right? Let's say you have multiple APs, but there's only one that you want it to mesh to. So then, at that point, you just enable the meshing only on those two access points.
That's right, yeah.
And go ahead.
Oh, go ahead. Oh, yeah, so, typically with our setup, you can do like a group configuration, and that includes like the radio settings, so you can enable meshing on all devices.
Right.
And then you can go in and then you can turn off meshing on specific APs and turn it off and turn it on if you want to. You can do it prior to the installation as long as you register the devices, but typically you do a group meshing, they're all meshing, and then you go in and then you start turning meshing off. So there's a couple ways you could do it.
And the reason to do that is when with Ingenious Cloud, when you're meshing, let's say on you mesh either on 2.4 or 5 gigahertz interfaces, but when you're meshing with an access point, they're all going to use the same channel. So you want to make sure if you're never going to mesh with most of your access points, turn it off so that they can auto channel onto another channel, so you have more spectrum that you can use, right? More throughput. Otherwise, they're all going to be on the same channel. They're going to be waiting for others to transmit before they can.
That's right. Yep. Yeah, we just dealt with that yesterday.
Yeah. So it's something to look for. Now there is a reason to have more than one gateway turned on though, because if there are two APs which are within the same distance to that mesh point, you'd probably want to turn at least two of them on, because that gives you redundancy. If like one was rebooting or was disconnected, it would connect back through the other one.
Or that's a really good point, because the other factor is with meshing, it's going to see where the fastest connection is going to be. So they can both be up,
right? But
the other connection could be faster at that particular time. So it's constantly checking. So having two is that's why you have meshing. So you have multiple.
Yeah, that is meshing. Yeah, it's preferred to do it that way. Yeah.
And it's checking for the fastest path back, right? So
it's using like an algorithm to check which one's faster. Now, one of those APs could be loaded. Somebody could be streaming, from a TV on one of the APs, so it'll go through the other one. Something like that.
The algorithm or the protocol is called Batman.
Is it really? It's like shortest path SPF protocol or something. I don't know, but it's called Batman. Is what they call it, huh?
Batman.
Yeah. Okay. All right. Well, yeah. So that's something to look for. Enable when you're doing Ingenious meshing. Maybe first enable it for the whole network. Get the APs in there. See which one it's connecting to, that it's preferring, right?
Yeah.
And then the other ones that are out of range of that mesh point, just turn them off because you want them to auto channel. And then the other thing we saw. What about the RSSI? Like, so you're in the Ingenious topology view. You look at the RSSI and it'll tell you like if the connection's good, bad, fair, whatever, right in there. That's what you want to do. Go in there and see what it looks like. But the RSSI numbers, it seems kind of low from what we're seeing, but it may that number may not be calibrated because of meshing or something like that, right?
Yeah, potentially. I mean, you were seeing a negative 88. I was seeing a negative 75, but I'm on 2.4. You're on 5 gigahertz.
Yeah.
So, but you were saying that your mesh point is pretty far, whereas mine's kind of far. It's gone through a lot of walls, I think. So, but yeah, like when you look at topology view, it will show you all the mesh points and all the gateways.
Yeah.
What they're connected to at that particular time. So, if I'm looking at mine right now and it's telling me, okay, I'm meshing on 2.4, what channel, what connection speed, or what speed, and then the connection status. It could be mine is currently good. It could be too far. It could be very strong. It depends on how far away it is. But I don't know what the different good, too far, very strong would give you in regards to like the RSSI. But it should. If you run your mouse over the link, it will tell you like the RSSI and if it's good or not.
So
right now I'm sitting at a negative 75 and it's good. It's a good connection. And I've never had issues updating that AP through mesh. Like if I do a firmware update, no problem whatsoever. And I've always had it connected. It's always been connected.
Yeah, I haven't either. I haven't run into problems of mine, and it's like negative 88, and it's still, or negative 85 maybe I'm seeing on mine, and it's still always up, and the connection's working well. Yeah. But in general, you want to place the mesh point in an area where it has like at least 50% signal, right? Like you don't want to put it too close to the wired access point because that doesn't make any sense. It's just going to confuse the clients. You want to put it where the signal is dropping off at least 50%, which means the clients will see less signal than the AP because the AP has better antennas and radios and things like that, right? So the clients will see less signal, but the AP still needs to be in a good signal area. You don't want to put the mesh point like out as far as you can, where you're disconnecting from the Wi-Fi.
The beauty of that whole configuration, right, is that you have the ability to mesh on 5 and 2.4. So if you do have to go at a far distance, you could mesh on 2.4, and you could and mesh. Just mesh on 2.4. Don't allow clients to connect on 2.4. Just mesh on it.
Right.
And you can crank up the output power on 2.4, and you'll get pretty far distances. But basically, you're using 2.4 as a backhaul.
Yeah.
So you have to keep that in mind. But if you're talking about just connecting like IoT devices that are too far away from your main access point and it needs help to communicate, you can get an access point. The access points have bigger antennas. You can adjust output power. You can choose to use 5 gigahertz or 2.4. So it just really depends on what you want to do. I configured mine on 2.4 because it's just talking to a Ring doorbell, for example, and garage door opener.
Yeah.
So it doesn't need a lot of data. And so I just needed the range, so I chose 2.4. But I didn't crank up the power. But you could crank up the power a little bit so you can get a good length, basically.
Yeah. So I mean, so with Ingenious you can choose the band that you're going to mesh on, and then you could disable that band for clients or leave it on so they can still use it. So there's it's not if you're going to do meshing, which we don't recommend doing it anyway, but if you're going to do it, there's going to be a little bit of optimization you're going to have to do for your situation.
Yeah. And then one thing I wanted to bring up too is basically if you just want to mesh on a particular band, you do not want clients to connect, just turn off, don't broadcast an SSID on that frequency.
Right.
You're totally fine. Yeah.
It's going to use, so that you won't have like high utilization, let's say on 2.4, because you're only using it for the mesh backhaul, and the clients you're going to have connecting on 5.8. But it's I would say do it the other way around because the IoT clients are going to be on 2.4, most of them. So use the 5.8 as the backhaul as your go-to. But if you absolutely need to get more range out of that mesh point, you could put it in 2.4 for meshing.
Mine's broadcasting right now, I think.
Yeah, and that's not a problem. I mean, I don't see, even when you're meshing on one radio, you can still connect to that radio clients, and it seems to be fine.
Yeah, totally fine.
All right, Bryan, anything else you want to talk about? Any new features on the Cloud app or anything?
Well, it's funny you brought that up. Yeah, so a couple just minor things coming out. The ability on the app to modify your SSIDs with band steering, turning on and off. The other one is dark mode.
Oh, nice.
Which is on the Cloud to Go app. So if you're using the app, you have the option to turn on dark mode. That's coming. That's not available to everybody yet. Anybody in our beta testing, they have the ability to be able to turn to dark mode. But yeah, a lot of capabilities in the app, down to configuring SSIDs, disabling SSIDs.
Yeah, it works, and it works on the 13. Like they changed the notch, so some apps like Instagram, they had to upgrade right away because the notch was interfering like with some of the buttons.
Oh, really?
Yeah, but it seems to work okay. It's not interfering with 13.
Yeah, so new dark mode, which is kind of cool. But yeah, make sure you download the app because the app has a lot more capabilities down to configuring and VLANs and tagging and untagging ports and SSIDs, turning on 802.11r, band steering, all kinds of stuff.
Yeah, they're adding more and more to the Cloud app. Pretty much everything that's in the website is now on the app.
Yeah. Yep. So yeah, I think that's the only thing I would bring up.
All right, sounds good. All right, well, remember to like and subscribe for more help with Wi-Fi. Post any questions in the comments, and we'll try to answer